Hi girls. Today we are going to see about the concept addressing modes of Intel 8085. So this is also one of the important concept in an Intel 8085 microprocessor. What is addressing modes? Addressing modes means how we access data from different parts of the memory. We are all know that the 8085 can access data stored in different parts of memory using instructions. Okay. But how that data is accessed is what is known as an addressing mode. How the data are addressed from the memory are known as addressing mode. For example, to make things simple, let us imagine a colony of warehouses of uniform sizes in a grid formation. Each warehouse has a number allotted to it, which is called its address. For example, if you take your house, you have a house number, address, and all the things like this. If you take the street, uh, in the street there are many houses. Each individual house have their own address. If someone want to post a letter for you, how your friends or your neighbors or any government letters reach your home by means of the address. Okay, so address is very important. So here, how the data is accessed from memory locations is called as the addressing modes. Here also, each warehouses in example, each warehouse has a number allotted to it, which is called its address. Also, assume that each warehouse has some goods in it. This will be our data, and every house and goods stored in it are referred to using the address. The grid shown below will help you to visualize it. Okay, so let us imagine what is addressing. Here there are a warehouse. Warehouse means where the content are stored in privately. For example, if you taken a grocery shop, the grocery owner have a godown or warehouse in some other places. Now from that they fetch the uh, content to their shop. Okay, like that in this warehouse, the warehouse numbers are, the first warehouse is 25 0001. So each warehouse has the address. The first warehouse address is 000. The second warehouse address is 001. Like that, here the series of warehouses are arranged. If you want to, this is the address means. This is the address of the warehouse 40. The 25H means the content stored in that particular warehouse. Okay, from the warehouse to 000 we can fetch the data 25. From the warehouse 0003 you can fetch the data 00. From the warehouse 0014 you can fetch the data 00H. Okay, from the warehouse 0021 you can fetch the data 00. Okay, so these are all the address, these are all the content of that address. So here how the data are accessed by using this memory or further classified into 5 categories. Before that, there are some special warehouses in the colony in which have special names allotted to them. These represent our registers. In microprocessor, Intel 8085 microprocessor, we have 6 general purpose registers. Already I explained you in my last classes. What are all the registers are B, C, D, E, H and L, and they are organized in pairs. Uh, how they organize means B, C, D, E and HL pair. Okay. While writing an assembly language program for 8085, we will use various ways to access data stored in the memory and the registers. We can access data from the memory as well as from the registers. What are all the registers? Here are the general register B, C, D, E, H, L. These are all the individual registers. Each register can store 8-bit data. If you want to store 16-bit data, then the register pair is used. You people can't able to pair the register. The Intel 8085 Corporation give the pair as BC as a pair, DE as a pair and HL as a pair. B register hold 8-bit data as well as C register, D, E, H and L. All these register hold 8-bit data. Okay, if you want to store 16-bit data, you can use this pair B, C, D, E and H, L. Here you can see in the example, this is the accumulator. Accumulator is also one of the register, but it is not general purpose register. It is used during arithmetic and logical operations. Here the accumulator stored the value 55. The register B have the content 00. The register C have the content 21. Like that, all the register have some values. Okay. So this is the types of addressing modes. Every instruction of a program has to operate on a data. Without data, we cannot operate. So every instruction of the program has to operate on data. That data is stored in a memory location or register or accumulator. Okay, so the type of specifying the data to be operated by the instruction is called addressing. The 8085 has 5 different types of addressing modes. The following are the 5 different modes. First one is implicit addressing, direct addressing, register indirect addressing, and the last one is implied addressing. Okay. Once again, I repeat this. Every instruction of the program has to operate on the data. For example, if you want to add two if you want to make addition of two numbers, we have the two value. Without value, we cannot do addition. Like the subtraction, multiplication, division, and all the operations are done by means of value. That value is called data here. That data is stored in either a memory or a register. How the values are accessed, how the instructions are operated are called as the addressing modes. Here, these addressing modes are classified as 5 types. This is the first one, immediate addressing mode. The name itself, you can see immediate means as soon as. In this mode, the number directly given by the programmer is moved into the specified location. This location could be a register or an address in the memory. Okay. It would be easy to understand the following example. Here, this is the first example. Move immediate. I means immediate. This is A. A means here accumulator. The value here is 25. The input data. The data here is 25. The data 25 is directly moved to the accumulator. So this is called the immediate addressing mode. The number directly given by the programmer is moved into the specified location. Here the data given by the programmer is 25. It is moved into the location accumulator, that is called as A. Here in the second example, the value given by the programmer during the execution is 62. That value is stored in the general purpose register C. In the third example, the value directly given is 45. That value is stored in the register B. Okay. Here in the last example, LXI H load immediate. H means memory HL pair 3050. 3050 means a memory location. So from that memory location, the value is transferred to HL pair. Here the load HL pair with the operand 3050H immediately. The HL pair is loaded with what the content in the 3050H. Okay. The second one is register addressing mode. Here register means both are the general purpose register. Source and destination both are a general purpose register. In the previous example, this is the source, this is the destination. Source is a data, destination is a register or accumulator. Okay, but here register addressing mode, both the operand will be registers. So in this mode, the data to be accessed and operated upon is present in a register, and it is accessed by specifying the name of the register. Okay. In register addressing mode, both the operand is only register. That means any general purpose register or accumulator. In the first example, you can see this is the destination, this is the source. Move A, B means the content of the register B is moved to the accumulator. Okay, so this is called the register addressing mode. Both operands are register. Here you can see both are registered. Here in this example, add B means the content of the register B is added with the content of the accumulator and the result is stored in the accumulator. Okay. Here the register A is called as the accumulator. It is inbuilt. You can, in my previous examples also I explained that this is an implied one. Add B means A equal to A plus B. Add the content of the register B with A and the result is stored in the accumulator A. The next example is INR. INR means increment. Increment here in this instruction, increment the content of the register A by 1. Okay, this is called the register addressing mode. The data to be accessed and operated upon is present in both or registered only. So the next one is the direct addressing mode. In direct addressing mode, the data to be operated is available inside a memory location, and that memory location is directly specified as operand. In the previous mode, register addressing mode, the operand, the data is available in register, but here direct addressing mode, the data is available in directly in a memory location. Okay. So here LDA 2050, LDA is the instruction, 2050 is the memory location. What is the meaning of this instruction is load the content of the memory location into accumulator. This is a memory. This means the memory means you can see in the previous in my example, this is the memory address 00H means. So here these are all the address, these are all the values. Okay. So in that address 2050, there may be a value is stored. That value is transferred to the accumulator here. Okay. In memory location 2050, there are some value will be stored. That value is transferred to the register A, that means accumulator. Okay. So LHLD address, this means they load the content of the 16-bit memory location into HL pair. The next one is direct addressing mode. In this mode, the address of the operand is given in the instruction itself. The address of the operand is given in the instruction itself. Here you can see LDA 2500. This means the address of the instruction. In that address, there may be some data is stored. That data was transferred to the accumulator A. Okay. So here the source is the memory location, destination is the accumulator. The next type is register indirect addressing mode. So in this register indirect addressing mode, the data to be operated is available inside a memory location, and that memory location is indirectly specified by the register pair. Okay, here you can use the register pair along with memory. Here you can see in the first example, move A, M. M means the memory location. It may be any of the memory address 2050, 3051, 4004, maybe any memory locations where the data is available is given here. That value was transferred to the accumulator. So move the content of the memory location pointed by HL pair to the accumulator. So you can see in this example, move A, M. M is the source. This means the HL pair, any memory location. A is the destination. The content of the memory will be transferred to the accumulator. So here this is the indirect addressing. Indirect means this is the memory address 2030. That value will be moved to the accumulator. The last one is the implied or implicit addressing mode. In implied addressing mode, the operand is hidden and the data to be operated is available in the instruction itself. Example, CMA. CMA means complement accumulator. A means accumulator. The content of the accumulator is find and stores the ones complement of the content of the accumulator, and the result is stored in the, and the flag will be affected according to it. RRC means rotate accumulator right by 1 bit. RLC means rotate accumulator A left by 1 bit. Okay, in this addressing mode, the operand is hidden and the data to be operated is available in the instruction itself. This is the example Again, this is the example of implicit addressing mode, CMA complement. Here, A is the source, A is the destination. Both are